Now we'll discuss expression for refractive index of Inosphere. Okay. So, what is the refractive index of Inosphere? Okay. So, you know that this is our Inosphere. This is my Earth surface. This is my Earth surface. And these are the layers of the air. So, this is D layer. This is E layer. This is F1 layer. This is F2 layer. Okay. So this is extended from 50 kilometers to 400 kilometers. 50 kilometers to 400. So we have already seen that here more number of free charge carriers are there. You have seen that the electron density in F2 is greater than F1 is greater than E is greater than D. So here more number of free electrons are there. Okay. So this is my transmitting antenna and this is my receiving antenna. So I am sending my transmitting antenna any frequency signal in between 2 megahertz to 30 megahertz signal will enters into the ionosphere and get reflected back. Okay. So whenever this what I have transmitted the signal. Whenever so I have transmitted the signal from this earth surface. This is my earth surface. I am transmitting an electromagnetic signal from my earth surface. Now it enters into the ionosphere. Now what happens whenever it enters into the ionosphere? Already free electrons are there. Okay, already free electrons are there. Whatever the electromagnetic signal that enters into the ionosphere, this exerts some force. This exerts some force present in the free electrons present in the ionosphere. Okay, so the radio wave passing through the ionosphere, the radio wave passing through the ionosphere, the radio wave passing through ionosphere, passing through ionosphere is influenced by the free electrons or charge carriers, free electrons of the charge carriers and the E field of radio waves set the electrons into motion. Okay. So let the electric field of EM wave is given except the electrical field of the EM wave is represented as E is equal to EM sin omega t. Okay. Now the force exerted by the electric field on each electron is given by F is equal to QE, or it is, since it is acting opposite, take it as minus QE. So you know that F is equal to mass into acceleration. Okay, so R m into dv by dt, where A represents the acceleration and V represents the velocity. Where V is the velocity. Therefore, m dv by dt, so minus epsilon into, from this dv by dt is equal to minus c by m into e. Okay, so applying integration on both sides, taking integration on both sides, taking integration on both sides, we get V is equal to minus E by M to integration of E of dt. What is the value of V? We have shown that the representation of the electrical field is equal to Em sin omega t. Therefore, the velocity V is equal to the velocity V is equal to minus E into integration of Em sin omega t into dt. Sin omega t into dt. So therefore, the velocity is equal to minus E into Em by minus of minus effect plus into M omega into cos omega t. Okay, so this is the expression for velocity. V is equal to E into small very charge. E stands for charge, charge of the electron into Em. M stands for mass of the electron. M stands for mass of the. So F is equal to E here charge into electric field E or mass into acceleration or mass into velocity. Okay, so this is the velocity. Okay, next. Similarly, we have assumed that here, for example, if you take a small cubic meter, okay, let n indicates, if n indicates number of electrons per cubic meter, capital N is number of electrons per cubic meter, then the instantaneous electric current, then the instantaneous electric current, instantaneous electric current due to these n electrons, due to this n electrons moving with velocity v, moving with velocity v. Okay. So due to this electromagnetic field, it sets the electrons to make into motion. Okay. So due to this, the electrons are moving with some velocity. Okay. So whenever the electrons are moving with some velocity, nothing but what is the current? The current is nothing but movement of electrons. This movement you are getting due to you are transmitting an electromagnetic signal into the free space. When this electromagnetic signal exerts some force on the electrons. Whenever the electrons are moving with velocity v, then the instantaneous current comes into picture due to, and it is the electrons are moving with velocity v and is given by the instantaneous current I is equal to minus n e. Okay. So what is this n? N is number of electrons per cubic meter. What is the C? Charge of the electron. What is that V? V is the velocity of the electron. So V is the velocity of that. So minus n into with the value of V. The value of V is this one. E and charge into, so it is the V is E into Em by M omega cos omega t. Okay, so therefore the instantaneous current is equal to minus n into E square into M omega into Em cos. So this is the instantaneous. This is the instantaneous. So this is the instantaneous current. This is the instantaneous current. So I is equal to minus NA square I is equal to minus NA square into EM into cos omega t. Cos omega t. Okay, so that is your instantaneous current. Okay. So besides this inductive current or instantaneous current, there is another current called as other current called as conductive current. There is another current called as conductive current. Okay. So this conductive current is obtained by the ionization of air. This conductive current is obtained by ionization of air. Okay, that is the presence of electrons and their motion. The presence of electrons. This is usually capacitive. This is usually ionization of air. This is usually capacitive current. This is usually the capacitive current. So the capacitive current is treated with the IC. Okay, or the displacement current, or the displacement current, or the displacement current existing exists in unionized air, existing in unionized air. Okay, so the capacitance, of unit volume is, that is K naught or epsilon naught is equal to 8.854 of minus 1 Okay. So therefore, the capacitive or displacement current, the capacitive or displacement current, the capacitive or displacement current through this capacitance, this capacitance is, this capacitance is IC is equal to rho by rho. So what is the relation between D? D is the from text density. D is equal to epsilon. Now that D is equal to epsilon. So that is rho by rho into epsilon. Rho by rho into now that D is equal to epsilon. So what is this epsilon E? Epsilon is equal to epsilon naught into epsilon R. So for free space, epsilon R is 1. For free space, epsilon R is 1. So therefore, epsilon is equal to epsilon. Okay, so D is equal to rho by rho T R epsilon into E. So therefore, this can be written as IC is equal to capacitive current is equal to epsilon into rho by rho T R. Okay, so assuming that, let us assume epsilon naught is equal to K naught. Therefore, IC is equal to K naught into rho by rho D of E. Rho by rho D of E. Okay, so what is the value of I? E? IC is equal to K naught into rho by rho D of E. Okay, so what is the value of E? Where E is equal to Em sin omega t. Therefore, IC is equal to K naught into rho by rho T of rho by rho T of Em sin omega t. So it is equal to K naught into Em into omega into cos omega ct. Therefore, the capacitive current, capacitive current, capacitive current IC is equal to K naught into Em into omega into cos omega ct. Let us consider this is as equation A. Okay. So similarly, the total current, we have derived two types of currents. One is instantaneous current, that is IA, and the other one is capacitive current IC. Okay, so the total current, IT is equal to the instantaneous current IE plus IC. Okay, so the instantaneous current IE plus C. Therefore, I total is equal to the value of IE minus NE square by MW into EM cos omega t plus the capacity current IC not equal to K naught into EM omega cos omega C. Okay. So here IT is equal to another thing I can take common here K naught into if I take initially EM cos omega sorry EM cos omega t EM cos omega t EM cos omega t. So my expression will be like this. It is K naught omega minus N square by M omega. Okay. So in this, if I take IT is equal to if K naught omega also take common K naught omega into EM cos omega t get 1 minus N square by M omega into K naught into omega. Okay, so K naught into M omega square. Okay, so let us consider this is equation B. Okay, so now let us compare one and or comparing A and B. Comparing A and B. Okay. So if you compare these two currents, okay, so if you compare this one and this expression, okay, so we compare the two expressions, okay, after comparing the two expressions, okay, the effective dielectric constant, the effective dielectric constant, the effective dielectric constant. K or epsilon. Okay, the effective dielectric constant or relative permittivity of the ionosphere. The ionosphere is K is equal to K naught into K naught into 1 minus M square by M omega square K naught. M omega square K naught. We know that epsilon is equal to general formula epsilon naught into epsilon r. Similarly, K is equal to K naught into KR. On this, epsilon r is equal to epsilon by epsilon. Similarly, KR is equal to K by K. Therefore, the relative permittivity KR is equal to K by K naught is equal to 1 minus N square by M omega square into K naught. Okay, M omega square into K naught. Okay, so there is a relationship between the relative refractive index and a relative permittivity. The relationship between refractive index mu and relative permittivity or dielectric constant is given as mu is equal to root of k. Mu is equal to root of k, that is root of 1 minus m square by m omega square into k naught. Okay, so this is very important. This is equal to root of 1 minus n into e square by m omega square k naught. Okay. So what is this here? Mu represents the relative permittivity. What is this? N indicates number of electrons per cubic meter. What is E indicates charge of the electron? What is the charge of the electron? Charge of electron, that is Q. Q is equal to 1.6 into 10 to the power of minus 19 coulombs. Okay. And what is this M? M indicates the mass of the electron. M indicates the mass of electron. M is equal to 9.1 into 10 to the power of minus 31 kgs. Okay. And what is this K naught? K naught is relative permittivity of the ionosphere. It is given as 8.844 into 10 to the power of minus 1 per meter. Okay. And this omega is nothing but omega is equal to angular frequency, that is equal to 2 pi f. Okay. And so mu is refractive index. Okay. So if I substitute all these values in the place of charge Q or E 1.6 into 10 to the power, the expression will becomes like this: mu is equal to 2 power 1 minus 81 n by f square. Very, very important derivation. This is the very, very important derivation. This is the expression for refractive expression for refractive expression for refractive index. Refractive index of ionosphere, where n is number of electrons present per cubic meter and f is frequency. F is the frequency. This is the very, very important expression. This is very, very important expression. Okay.